Hi guys, welcome to your screencast on mechanics of breathing. Now it's really important you make key notes on this. This didn't come up in January, which means it could potentially come up this time around. So why is it important to know about mechanics of breathing? Well, it's because it changes from rest to exercise. So they might try and catch you out with regards to a question they ask you. Now, there's two phases with regards to mechanics of breathing. This is breathing in, inspiration, and breathing out, expiration. What I'm going to do is just to kind of jog your memory, you're going to have a quick fill in the blanks again when it comes to mechanics of breathing at rest. Okay, so inspiration and so forth. So I want you to give that a go. Just pause this and give it a go. Right, okay, so mechanics of breathing at rest. What happens? The diaphragm, it contracts and flattens. This is when we're breathing in. Okay, breathing in, inspiration, is an active process. Our muscles contract. So diaphragm contracts and flattens. The intercostal muscles, the external intercostal muscles contract. Ribs move up and out. Thoracic cavity volume increases. Thoracic cavity pressure decreases. Air rushes into our lungs. Now, at rest, expiration is completely passive. There are no muscular contractions happening whatsoever when we're just at rest, chilling, watching TV, whatever. The diaphragm just relaxes and moves back up. The intercostal muscles, the external intercostal muscles relax, ribs move down and in, thoracic cavity volume decreases, thoracic cavity pressure increases, air rushes out of our lungs. So that is what happens when it comes to mechanics of breathing at rest. Now, here is an exam question. It's 5 marks. I'm going to give you a memory method to use to remember this if you can't remember it from our lessons. Describe the mechanics of breathing for expiration at rest. There are 3 key points we have to remember within this whole question. First of all, mechanics of breathing. Whenever you see a question asking about mechanics of breathing, you have to think to yourself, okay, mechanics, they fix things. Okay, that is what they do. Breathing, humans breathe. Where do we go when we need fixing? We go to a doctor. Doctor VPA is how we're going to remember the mechanics of breathing. Get that down if you haven't got down already. What else we need to know about this question? It's talking about expiration and it's talking about it at rest. So we need to try and work out, okay, what do our mechanisms of breathing do during the expiration and during rest? If you think you can answer that now, give this a go. Pause it and give it a go. Okay, so here's your memory method, Dr. VPA. Now try and use that to help you out. If still not, we'll go through the answer now. So pause it. So, describe the mechanics of breathing for expiration at rest. The diaphragm relaxes and moves back up. External intercostal muscles relax. Ribs move down and in. Thoracic cavity volume decreases. Thoracic cavity pressure increases. Air rushes out of the lungs. Now, obviously, you're going to have to be able to write this in paragraph form, as I've just put a note down here for you. If you can now, what I want you to do is answer this question. Describe the mechanics of breathing for inspiration at rest. Pause this and then look back at your notes once you've answered the question. Okay, so that is at rest done. It's simple. The memory method we use, Dr. VPA, is still the same during exercise. However, we need to remember that during exercise, everything is exaggerated. So mechanics of breathing during exercise equals exaggeration. You have to remember exercise, exaggeration. If they say to you a question with regards to someone running, running is exercise, exercise, mechanics of breathing, exaggeration is exaggerated. There are extra muscles involved, but I do not want you, for the purpose of this, if you want to and you think you're going to remember them, give it a go. However, I'm not going to go through them for this screencast, okay? So first of all, inspiration during exercise, exaggeration. Diaphragm contracts and flattens with more force. The external intercostal muscles contract with more force. Ribs move up and out further. Thoracic cavity volume increases further. Thoracic cavity pressure decreases further. More air rushes into the lungs. Now, during expiration, I just said to you at rest, expiration is passive, no muscles contract. However, it is different during exercise. That's all you need to know, that during exercise, muscles do contract. What does this cause? This causes things to move up and out or down and in further, increasing further, decreasing further, and we'll just go through it now. So the diaphragm relaxes more and moves back up, exaggeration, okay, more. External intercostal muscles relax more. These are the additional muscles that contract with regards to expiration during exercise, but don't worry about them as long as you remember these further, 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 and more, more. Ribs move down and in further. Thoracic cavity volume decreases further. Thoracic cavity pressure increases further. More air rushes out of the lungs. Why are these two important? More air rushing into lungs, more oxygen on board, more oxygen getting to the working, well, more air coming on board, which means you've got more oxygen going to the working muscles, which means we can perform for longer at higher intensities, reducing fatigue. Expiration, we breathe out more carbon dioxide, which means we can perform for longer at higher intensities, reducing the effect of fatigue. Okay, now I want you to answer this exam question. Evan is a competitive triathlete and needs to prepare his body to meet the needs of the swimming, cycling, and running sections of his event. Describe the mechanics of breathing for inspiration during the swimming section. So, what we're going to do is circle mechanics of breathing or underline it. Next to it, mechanics of breathing, Dr. VPA down the side. We're talking about inspiration, so we need to be regard to breathing in. During swimming, swimming is exercise. So once you put Dr. VPA at the bottom, put exercise, extra exaggeration. Once you've done that, I want you to give this question a go. Pause it and we'll go through the answer now. The external intercostal muscles and diaphragm contract and flatten with greater force, which moves the rib cage upwards and outwards further, which results in a greater increase in the volume of the thoracic cavity. So there's a greater decrease in pressure within the thoracic cavity, causing more air to rush into the lungs. Okay, that is the answer for that question. There's 5 marks there you should be getting. Right, so now we know that when we exercise, we get those increases happening because we're getting muscular contractions taking place. What we need to know now is, well, how does that happen? That all happens because the control of breathing, specifically the neural control of breathing. So control of breathing, what we need to know is, at rest we have normal breathing rate, okay. Then we start to exercise. When we start to exercise, chemoreceptors detect an increase in carbon dioxide. This sends a message to the RCC, which is in the brain, the respiratory control center. This sends a message which basically increases our breathing rate. During recovery, chemoreceptors detect a drop in CO2, sends a message to the RCC, reduces breathing rate, and we're back to rest again. That is the control of breathing. However, we need to know it with specific regard to a question that might be asked in an exam. So what makes our breathing rate increase, decrease? Respiratory regulation is the answer, specifically neural control. Neural control, respiratory regulation during exercise. Receptors, chemoreceptors detect an increase in carbon dioxide. This sends a message to the RCC, which is in the brain, respiratory control center. They'll accept RCC in the exam. This then sends a message to our Dr. VPA, telling us to either increase or decrease our muscular contractions and so on. What I want you to focus on is when you see neural control or anything to do with neural and respiratory system, you have to think neural equals brain equals emergency. Emergency, our memory method is ring Dr. VPA. Okay, ring because you're going to stutter because you're kind of all flustered and you're panicking. So ring, I need to ring Dr. VPA. Okay, so what you get from that is you get our receptors. Chemoreceptors detect an increase in carbon dioxide. This sends a message to the RCC, which is in the brain. You can say medulla oblongata, you don't need to, you can have RCC. What does this do? This makes our diaphragm contract and flatten with more force. It makes our external intercostal muscles contract with more force, and so on. Ribs and VPA, okay? That is how you go through this process. So what I want you to do now is answer this question for me. Explain how neural factors regulate Evan's respiratory system during the cycling section of his race. What you do is, you've got respiratory system in and neural factors. Straight away, you know they're asking about chemoreceptors and mechanics of breathing. So, neural, underline it. Neural, brain, emergency. I've got to ring Dr. VPA. So give that a go and then we'll go on to it now. The answer. So the answer you gave, if you're using a Dr. VPA, is going to be a lot more in detail than this one here. So that'll specifically 100% get you 4 marks. First of all, during exercise, having an increase in carbon dioxide, correct? Chemoreceptors detect this increase, send a message to the RCC in the brain, which increases depth and breathing rate. That's 4 marks. If you put there's an increase in carbon dioxide, which is detected by chemoreceptors, you send a message to the RCC, then you went, this means that the diaphragm is going to contract and flatten with more force, and went through that whole process, you're going to be getting 4 marks, okay? Please ensure that you have clear notes for this section because it is important. I think it will come up again, so be aware of it. Thank you for listening, and I'll see you soon. Bye.